Hi, I'm Sean Murphy. I'm a surgeon at Westfed Emergency and Specialty Center in Boise, Idaho. And today I'm going to be talking about some of the ways that we apply the Arthrex OrthoLine plates, as well as how those plates integrate with current systems. So just an overview of the plates in general. We have approximately 7 different plate sizes, and they're both in stainless steel as well as titanium varieties. On the left, you'll see that the 1.6 and 2.0 millimeter plates are able to be interchanged with screws. That is, the 2.0 screws can certainly be used in the 1.6 screws as well as vice versa. With the 2.4 millimeter plates, we only use the 2.4 millimeter screws, and that's similar in the 3.0 millimeter plates. Both of those plate systems have a variable angle locking screw as well. With regards to the stainless plates, that is the 3.5 and 3.5 broad, both a 3.5 regular cortical screw as well as a 3.5 locking screw may be used. Additionally, we've designed a 4.0 millimeter screw to go along with these stronger plates so that you have improved plate screw strength. General applications of locking plates and general applications of the Arthrex OrthoLine are similar. We want to maintain a plate screw density of approximately less than 0.5. Shown in this example here, you'll see that we have about 0.46 in terms of our plate screw density, with 6 screws placed over a 13-hole plate. Now, lowering the working length in any construct may increase the stiffness of that construct. And when we have a larger fracture gap with something the size of 6 millimeters or greater, we actually want to place our screws closest to the fracture to decrease the plate strain. With regards to a smaller fracture gap, leaving 2 to 3 holes open will actually decrease plate strain in gaps less than 1 millimeter. Additionally, approximately 80% of the bone should be spanned with the plate, or 3 times the length of a comminuted fracture segment. With regard to plate length, matching the plate length to approximately 80% of the bone is typically recommended, or approximately 3 times the length in a comminuted fracture segment. In load-sharing applications, we want to gain 2 bicortical screws and at least 3 to 4 screws in a bridging application of the plate. With regards to the bone-plate interface, we want to hold that plate within approximately 2 millimeters of the bone in a locking application. We've given multiple temporary fixation options with the Arthrex plate. The first is a BB tack that can be used to temporarily fix the plate to the bone. The second is a cannulated bending plug, such that you can place a bending plug in any universal screw hole and then place a K-wire through that. The third is just a standard K-wire screw hole. After temporary fixation of the plate to the bone using those 3 applications, the compression and slide holes are used to apply the plate. The slide hole is used first as it allows for the cortical screw to be placed and then a small amount of movement to be performed within the plate relative to where that plate sits on the fracture. Next, a locking screw is placed to affix the plate to the bone on the slide hole side of the plate. Finally, the compression hole screw is drilled and the fracture is placed into compression in those types of applications. When drilling the compression hole, we can aim for 100% of interfragmentary compression, and we can use the whole ramp of the compression hole. If we want to have a little less compression, because this is a relatively aggressive compression hole, then we can drill at the 50% margin. A 3.5 plate placed in 100% compression moves the bone segment approximately 3 millimeters. With the variable angle screw application, a conical shaped drill guide is first placed within the hole, and then the drill hole is free-handed with up to 12 degrees of variation using the guide. The screw is then placed along that pilot hole. As far as integration goes with stainless steel plates, the variable angle screw is not currently available. However, the universal drill guide, K-wire holes, as well as depth gauges, screwdrivers, etc. can all be used. A 4 millimeter locking screw is also available with this application to increase the overall construct strength. With regards to the titanium sets, the 2.0 and 2.4 sets are interchangeable and can use the same screwdriver, locking cortical screws, as well as K-wire holes. The 1.6 does allow for placement of 2.0 screws within that construct. With regards to the 3.0 set, it does not integrate with the 2.7 set, as these are a stainless steel implant as well as titanium. However, the screwdriver and depth gauge can be used. Thank you.